All right. There we go. So we had previously talked about the quadratic formula, right? I think it may be over here. Yeah, the quadratic formula. And we got this equation because we solved the we started with the generic standard form for a quadratic equation, ax squared plus bx plus c. This should be, say, equals 0. This was our standard form. And we said, okay, well, what happens if we set this equal to 0 and just try to solve for x using something called complete the square? So that's exactly what we did. Had ax squared plus bx plus c equals 0. And we try to complete the square, because complete the square is a way that you can solve these quadratic equations. The whole problem is that if we have something like this, and you just try to get t by itself, you're not going to be successful. It's just not really possible unless you do something called complete the square. And so when you complete the square in the generic form, you end up with this equation. And now I'm using t, but you can also use x. It's whatever your variable is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. It's probably worth memorizing this. I think you have to memorize it in one of your math classes, I'm pretty sure. And it is, you might as well just remember it. It's not too bad. There's a little story you can come up with, or a song. I'll sing a song for you. Yeah. Some people said the videos are dry, so this is my attempt to help here. There are two versions of the song you can sing. You can sing it to Row Row Your Boat, or Pop Goes the Weasel. I'm going to choose Pop Goes the Weasel because it's just a little bit more interesting to me. And so the equation you can sing it like this. T is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. There you go. So again, there's also a story. I'm going to tell this story because it's good. Okay, so you have Bob and Bill, right? Bob and Bill are two guys. So Bob and Bill, there's two of them, b squared. All right, well, Bob and Bill are rich. They're like really rich, okay? And so they live in this really radical house. And they have also, in addition to this radical house, they have this butler, right? So Bob and Bill have this really nice life. They have the radical house and their butler. And one day they invite they meet these 4 awesome chicks, and they invite them over to have a party. So like, hey, you 4 awesome chicks, you should come to our radical house. So the 4 awesome chicks come to the radical house, okay? But the problem is that one of them accidentally hit the wrong switch, and they opened up this trap door, and underneath the trap door were these 2 alligators. 2 hungry alligators were in the basement. And unfortunately they fell in, and these 4 awesome chicks were eaten. They're gone. They're minus 4 awesome chicks now because they got eaten. And the families of these 4 awesome chicks, understandably quite distraught, sued Bob and Bill, and they lost their butler and they lost their radical house. And that's the story, the tragedy of Bob and Bill. So you can remember it like that too, but again, just remember it somehow, right? Because you do use it in like you'll probably use it in 2 or 3 classes, so it's worth just memorizing at some point. But anyways, negative b plus minus square root of b squared minus 4ac all over 2a. Now it's very important, this all over 2a stuff. Sometimes people get sloppy and they just write over this part, but the whole thing is basically dividing by 2a will be the very last thing you do. Everything else will come before that. All right. Oh, I don't know where I'm going. Let me go back. All right. So anyways, I'll erase this. This is what we have. Well, we can use this equation to solve this. And while we will be completing the square, you won't have to go, okay, well, this is a, or this is equal to 2a, so we set it equal to a, and a is going to be 10, so then we have to add a squared to both sides and all that. Like, you don't have to actually do that. That is what you're really doing, but you can just use the quadratic formula to kind of guide you through those steps. And the way the quadratic formula works is there's an a, b, c, and d, as you can see here. So A, B, C, and D are certain numbers. Okay, A is going to be the coefficient on the squared part. B is going to be the coefficient, right? And it all comes from ax squared plus bx plus c. Or again, understand this time we're using t's, but a t squared plus bt plus c. Well, the thing in front of x squared or t squared is going to be a. So a is going to be just the number 4.9, the coefficient 4.9. B is going to be, in this case, in front of T or X, and that's 20. And then C is going to be whatever's left over there at the end, plus C, plus 200. And these could be negative numbers as well. A, B, and C could be negative, but you don't put the squared parts or anything like that. It's just the coefficients. All right, so we've got, I'm going to move this up a little bit. T is going to be equal to negative B is negative, and I'm just going to plug in all the numbers. This is a T, by the way. I know it definitely looks like an F, but it's a T. Negative B plus or minus the square root of B squared minus 4AC. All over again, don't get sloppy on that, 2A. Alright, well, I have made a mistake that I need to rectify right now before we go any further, and it's literally up here is my mistake. This should be negative 4.9 because, of course, gravity is going to be pulling it downward, so I'm going to change this to negative 4.9 and this to negative 4.9. Alright, so just mark that change in your notes or whatever, but that's what I'm doing. Alright, so now I've got this. This is really just a calculator problem, but here's the thing. I am not going to teach you necessarily how to plug it all in the calculator. Some of you can do it, some of you can't, but that's not on me. I'm not going to teach you that. I'm going to teach you the just method of just breaking it down bit by bit. If you can plug it all in the calculator, that's fine, but be warned, you may miss it because you plugged it all in the calculator and you're not going to be able to tell. Alright, so I need to get my regular calculator, so I'll be back. Hold on. Alright, I have my calculator. So here we go. First thing is 20 squared, which should be 400. Had to double check myself. So I'm going to start simplifying. Negative 20 plus or minus. We'll talk about plus or minus in a second. Square root of 20 squared is 400. Here's another big part where people mess up. This right here. I'm going to do minus, and I caught myself again. Okay, you need to change this too. 4.9 is negative, right? But I didn't change it right here. It should be negative 4.9 right there. Again, all that's changing is the sign, but it will be very important. So I have 400 minus, now, in my calculator, this is the way I kind of see it. I kind of see it like this. We're going to take 20 squared minus whatever 4 times negative 4.9 times 200 is. And that's the way I do it on my calculator. I'm about to plug in 4 times negative 4.9 times 200 and then subtract whatever I get. Sometimes you want to do like negative 4 times negative. If you want to do that, that's fine, but you have to do a plus sign. So you have to do 20 squared plus negative 4 times negative 4.9 times 200. So I'm just going to leave it like this. All right, 4 times negative. So when I did this, 4 times negative 4.9 times 200, I get negative 3,920. Okay, so I have 400 minus negative 3,920. This is fun that you have minus negative. In fact, it's good that you have minus negative because we want this to be positive at the end. Alright, I will tell you now, all the answers should, unless I make a mistake, should be real numbers. So if you get like an error, imaginary number, or like an error or something on that square root part, you have plugged in something wrong, is all I can tell you. On the bottom, 2 times negative 4.9 is negative 9.8. Man, you can't get rid of that negative 9.8. It's just going to keep coming up. Alright, so we have this part. Let's simplify a little bit more. Now I have negative 20 plus or minus. I have 400 minus negative 3,920. That gives me positive 4,320. So this is the square root of 4,320 over negative 9.8. So I can take that square root, the square root of 4,320. You see, you definitely need a calculator on this. It gives me 65.7. So I have, in final little bit here, negative 20 plus or minus 65.7 divided by negative 9.8. Alright, now at this point, let's address the plus or minus. Again, it's called plus or minus, but it really should be plus and minus. So hopefully you have everything now, because I'm about to erase this stuff over here because I need more space. You understand how we got this? We should use quadratic formula. It's a lot of stuff, but, and again, if for some reason you're like, no, I didn't have that, stop erasing, you can just obviously rewind the video, right? You can just go back. It's still here. It exists. on the YouTube. It still exists. Alright, so this is really going to branch off here. This plus or minus is going to be plus and minus. One time we add, one time we subtract. So on one part we're going to go negative 20 plus 65.7 divided by negative 9.8. On the other hand, we're going to go negative 20 minus 65.7. Oops, 65.7 divided by negative 9.8. Okay, so be careful here. You all should be strong enough in your basic math to understand that you cannot just plug negative 20 plus 65.7 divided by negative 9.8 on a calculator and expect to get the right answer. You won't, because you have to do it separately. You have to add first and then divide, because if you plug it on the calculator, it'll divide first and then add, and that's incorrect. So I literally, I'm not kidding, I just do it in 2 steps. I do negative 20 plus 65.7, and on top I get 45.7, which you could probably do without a calculator, but I already typed it in. Okay, and 45.7 divided by negative 9.8 gives me negative 4.66. Okay, so let's look at the green. Negative 20 minus 65.7. Let's try that. Negative 20 minus 65.7. Oops. Negative 20 minus 65.7. And then divided by negative 9.8. Oops. Sorry. I do it in 2 steps, right? Which I do on my calculator. I just didn't write it down. Negative 20 minus 65.7 gives me negative 85.7, obviously. But then divided by negative 9.8 is going to give me positive 8.74 seconds. There you go. You have 2 answers. Now it's probably a little bit strange because, well, we're used to having 1 answer. But again, these are quadratic equations. There are 2 spots because graphically, and actually we may do an exercise as a bell ringer soon where we actually graph it out, one of these. But basically, I mean, the basic graph is going to look something like this, right? If this is my Cartesian coordinates. At 0 seconds, we know it's going to be at 200, right? Because 0, 0, 2 plus 200 is going to be 200. So at 0 seconds, it's actually going to be all the way up here at 200. And from there, it's going to come down as a parabola. I know it opens down because that first term is negative. Again, that's why it's very important that this is negative. It opens down because it's negative. And so you're going to get a parabola that looks like this. I know it opens down because it's like negative is like a negative is like bad or a frowny face. So I think negative makes a frowny face, and that's how I remember it. But anyways, obviously this is going to go downward, and there should be 2 answers. One will be 4.66, and one will be 8.74 because, or sorry, negative 4.66, because there are 2 points where it crosses the 0. X equals 0 mark, which is what we're looking for, right? We set it equals 0. We'll know, okay, what times do we get 0 for this? Because again, in the grand scheme of things, we're trying to figure out when does this thing hit the ground, and we have 2 possible solutions. Mathematically, both are correct, but logically, only one of them makes sense. So we say, okay, either it hit the ground in negative 4.66 seconds. Okay, in other words, it hit the ground. If this is like, I don't know, something being thrown up in the air. Okay, but it hit the ground 4.66 seconds before it even threw it, which doesn't really make sense, or it hit the ground 8.74 seconds after we throw it. And clearly this is going to be the right answer. But mathematically, that's why we get those 2 answers, because there are 2 points where this parabola, again, we're using this as a model, right? This quadratic equation is a model of this object's vertical displacement, how high its height. Well, the model doesn't care about negative time. Okay, negative time, fine, just as a negative number, I can deal with that. The model doesn't care. Now, we know that realistically, we don't really care about this stuff over here. It didn't actually happen. This is what happened, but the model doesn't. So when you do this, you will get 2, and you can't always say it's always going to be minus or it's always going to be the plus. Like, it changes, so you really do have to find both solutions. So anyways, this is where we got. And so after 8.74 seconds, it's going to hit the ground. So this is a huge statement. I know it doesn't seem like a lot, but it's so important that we can say it. We can now say, okay, after this object is launched, 8.74 seconds later, it's going to hit the ground. And that's super important, because when we find the range, the next part is like so easy. The thing about range is finding this time is very kind of difficult, right? I mean, we did a lot of work. This is like the 4th video going into this. but actually applying it's quite simple, and that's what I'm going to show you in the next video, which will be the last one, I believe.